Okay, so in this video we're want to go over this example. It's from our textbook, so it comes from what section? It's 1.5, modeling in 3 dimensions. So it's a nice problem that kind of uses a lot of the material that we've covered in this volume section. So it says that an 11-inch tall roll of paper towels has an inner cardboard tube with a diameter of 1.5 inches. The width of the paper towel on the roll is 2 inches, right? And each paper towel is 0.015 inches thick. Okay, so the way we want to, and question 1 is, what is the volume of paper towels? Will the volume change if the roll of paper towels is unrolled? So the way I want to think of it for the first part is almost think of like that roll of paper towels. They're kind of tightly wrapped, so it's completely, you can think of it like a solid almost, right? And of course there's a hole in the middle there, so you can kind of slide it into some kind of dispenser. Okay, so we want to identify the volume of this cylinder, right? In other words, the volume of the whole paper towels, right? And we'll think of it, we don't need the thickness for part 1 here, right? We'll just think of it as, right, one solid piece here with that center cut out. Okay, so let me switch over here. Okay, so what we have is 2 cylinders, right? So we have a cylinder with the inner part kind of cut out. And we've covered a problem like this before. So to get the volume, we'd have volume of the outer cylinder, which I'll just call OC, minus the volume of the inner cylinder. All right, and each one of those, right, is going to be the formula for the cylinder. The volume of any cylinder is pi r squared height. Right, so the volume for the outer one is, we have a, so here let's actually determine what the radius is, right? So if we recall here, so let me switch back to, so let's keep in mind here that those 2 inches, they don't give us the exact radius here, right? Here what they give us is, in the first part, the inner part, they give us the diameter, which is 1.5, right? So the radius of that inner one would be half of that. So 1.5 divided by 2 is 0.75. All right, and now keep in mind 2 inches is just from the outer edge to where we have the outer cylinder here, or the inner cylinder, excuse me, to the edge of the inner cylinder. So here, let me now go back here to my notes. Okay, so based off of that figure, right, the inner radius here is not 1.5, but it'll be half of that. So it'll be 0.75. And then the outer one would be that 2 inches, but also that 0.75. So it'll be 2.75 inches. And of course, they'll both have the height of, what was it, 11 inches? 11 inches. Okay, so the volume of the outer one is pi, radius 2.75 squared times 11 minus pi, radius of the inner one is 0.75 squared times the height of 11. Okay, so I'm just gonna type all this into my calculator here. 2.75 squared so we get a total of 77 pi. Okay, so that answers the volume, and this would be, again, Obviously, let's not forget units here. Inches cubed. Okay. All right. Now, the second part of the question asks, will the volume change if the roll of paper towels is unrolled? And it will not change, right? If we think of it as a whole solid just rolled out, it would not have an effect on the volume, right? In fact, what will happen here, you can think of the whole thing rolled out as a very, very short rectangular prism, right? Where the length here would be 11 inches. I'm not sure what this is here. That would be unknown. That would be unknown, right? Actually, I think part 2 asks us that. And it'll have a little bit of thickness, right? It'll have the thickness here, if we think of this as a box. It's kind of being unrolled out here. Excuse my drawings here. 3-dimensional drawings on a 2-dimensional surface is not my forte here, but we get the idea, right? We can think of it as a very, very short prism, right? With a thickness that was given to us of what, 0.015 inches. So the volume would not change. It would just be in a different form. It would no longer be in this cylinder type thing. It would be just some long rectangular prism. Now, which leads us, so the volume would be unchanged, which leads us to trying to answer the second part of this question, right? So here, let me, so the second part of this question asks, if the whole roll of paper towel is unrolled, how long will the chain of unrolled paper towels be? And it gives a little hint. Use your answer to number 1 to help. Okay. So if we've agreed that the volume is unchanged, that is going to help me out, right? So going back here, if now our volume formula changes, right? The volume of a rectangular prism would be length times width times height. Okay, so I know the volume, right? I found that out in the previous problem, right? So we could say the volume is 77, length is 11, right? I don't know what the width is, right? That is going to be my x, but I do know the height, right? The height is 0.015. Okay, so multiplying this out, we get 77 to be equal to 0.165x, and excuse me, I forgot, pi. And now divide by 0.165. So in this case, I will just give a decimal approximation. So we get x to be 77 pi divided by 0.165, and that gives me 1,466. I'll go just one decimal place, 0.1, and units here is a unit of length, so this would be inches, right? Which is roughly about 122 feet of paper towels. All right, so that's how we would answer this question here.